This video provides direct instruction for how to solve multi-step algebraic equations and how to check the solution to make sure you got it correct. All right, first step is you want to separate the equation into the right and left side of the equal sign. So a lot of times we just like to draw a line right down the middle of the equal sign so you can clearly see the left side and the right side of the equation as you work through it. For this video, I have my slides pre-done, so I'm not going to keep putting the dividing line up there on the slideshow. All right, so next step is we're going to remove all parentheses by using the distributive property. So we're going to come up here and go 7 multiplied by 2x gets us 14x. And then 7 times the negative 5 gets us the negative 35. Then do not forget to write the rest of your expression out on the left side, 15 minus 10x. Equal sign, now we do the distributive property on the other side. 2 times x is 2x. 2 times 9 is 18. And then don't forget to write the rest of the expression, negative x minus 20. Now, many times there are no parentheses given in the equation, so you can just skip this step in that case. Also, a lot of times there's just parentheses on one side of the equal sign, so you just do it on the one side where the parentheses reside. Our next step is to combine like terms on the left side and the right side of the equal sign. So we're going to do that by 14x is by itself. No, it's not. Sorry, 14x and negative 10x here. We're going to combine those. That's how we get the 4x. And then we're going to combine the negative 35 and the 15 to get the negative 20 here. We're going to do the same thing on the right side. We're going to combine the 2x and the negative 1x. That gets us just 1x. And then we're going to combine the 18 and the negative 20 to get us the negative 2. So now our equation is 4x minus 20 equals x minus 2. Next, we're going to use inverse operations to isolate the variable term and the constant term. So we want the variable on one side of the equal sign, and we want the number on the other side of the equal sign. So remember, equation equal means it's the same on both sides. If you think about a scale, the weight is 100 pounds on the left and 100 pounds on the right. And so we've learned that what you do to one side of the equation, you must do to the other side of the equation to keep that scale balanced. So what we're going to do here, we have 4x minus 20. And so we're going to undo that subtraction of the 20 by adding 20 to both sides. Sometimes people say we're going to add the opposite. So if it's negative 20, we're going to add 20 to make that 0 on the left side. So you think that left side becomes just 4x plus 0, but we don't need to write plus 0. On the right side, we add the 20 as well. So now we get the x plus 18 because negative 2 plus the 20 is 18. So again, if you started with a scale, you got 100 pounds on both sides. If you add 20 pounds to both sides, now you have 120 pounds on both sides. Still equivalent. All right, we want to get the x on the left side in this example. So we're going to move the 1x here. So we move 1x by subtracting x from both sides, which is called the subtraction property of equality. Or you could say you want to add the opposite. So we're going to add negative x, negative 1x to both sides. Either way, you end up getting 3x equals 18. Now that we have the x isolated on the left side and the number isolated on the right side, we want to solve for 1x. So we're going to use inverse operations again to get this to become 1x. So ask yourself, how are the 3 and the x tied together? That's right, they're tied together by multiplication. It's 3 times x. So we're going to undo that multiplication using division. So we're going to divide both sides by 3, the division property of equality. So 3 over 3 becomes a 1, so it's 1x. And then 18 divided by 3 becomes 6. So again, thinking of that scale, if I have 120 pounds on both sides of the equation, if I divide both sides by 3, 120 divided by 3 is 40. I have 40 pounds on both sides of the equation. It's still balanced. So x equals 6 is our answer. What do we do next? That's right. We are going to check our solution using substitution into the original equation. It's important that you go all the way back up to the original equation. Sometimes students want to just go, well, I just want to do it right here. It's nice and easy, light work. That's a true story, Problem is, if you made a mistake to get to that 3x equals 18, it's going to check out as correct. But you actually made a mistake. It's not going to work in the original equation. So you have to go back to the original equation, and you're going to take that 6, and you're going to substitute it wherever you see an x, right? So we can substitute it there. We're going to substitute it here. We're going to substitute it here. We're going to substitute it here. So in this one, we have 4 places we're going to replace the x with the 6. And then we're going to follow the order of operations, right? So it's 7, and then parentheses 2 times 6 minus 5 plus 15 minus 10 times 6 equals 2 times 6 plus 9 minus 6 minus 20. All right, so then 2 times 6 is 12. 12 minus 5 is how we got the 7 here. So now it's going to be 7 times 7 plus 15 minus the 60, because 10 times 6 is 60. We're going to get 2 times 15 because we went 6 plus 9 to get 15, and then minus the 6 minus the 20. So now we have 49. If we do the multiplication here, 49 plus 15 minus 60 has to equal 2 times 15 is 30. 30 minus 6 minus 20. So then we end up adding and subtracting those values, and we end up getting 4 equals 4. That is true, so we'd like to say check, it works. But you may come across where you get 4 equals 5, or 4 equals 0, or 4 equals negative 4. Those are all false. If you get a false statement, that means you made a mistake. You either made a mistake in your solving your equation, or sometimes students made a mistake actually on their check using the order of operations. You made a little bugaboo there. So you just got to go back, check your substitution work. Did you check it out correctly? Okay, you did that. And then let's check you got to go back and rework your equation to make sure you got it right. Let's walk through another example. This time I'll write it on the screen so you see as we're going. It's all on one slide here. So separate the equation into the right and left side. We're going to just draw that line right down the middle here. That's the first step. Next step, we want to remove the parentheses if they're in the equation. In this case, we had just one set of parentheses. So we're going to do 2 times x and 2 times the negative 5. So we're going to have here 3x plus 2x minus 10 equals 25. Okay? Now we are going to combine like terms. Sorry for my chicken scratch here. It's hard to do this on the screen here. But 3x plus 2x gets me 5x minus 10 equals the 25. All right. So now we want to use the inverse operations to isolate the variable on one side and the number on the other. In this case, I'm going to go ahead and keep my 5x on the left. I want to move that negative 10. So I'm going to add 10, right? It's 5x minus 10, inverse operations addition. Again, we know what we do to one side, we must do to the other to keep the equation balanced. So now we have 5x equals 35. All right. Now what we want to do is we want to use inverse operations again to solve for the variable. We want 1x. Okay, so 5 times x, we're going to undo that multiplication with division. So we're going to divide by 5, divide by 5. So now we get x equals 7. That's our answer. But we need to now, that's right, check it. So we are going to check it now. And so substitute into the original equation, we're going to go 3 parentheses 7 plus 2 parentheses, boop, I'm substituting that 7 in for the x there, minus the 5 equals 25. All right, 3 times 7 is 21 plus 2 times 2 equals 25. So I get 21 plus 4 equals 25. So then I'm going to get 25 equals 25. Check. Thanks for watching. Hope this was helpful.